Welcome to Brain Vision.
So here the wavelength lambda is 0.75 meter. So to find out the frequency, we can use equation 11.12, which is speed of wave is equal to frequency times wavelength. And from there, we can write frequency is equal to speed of wave by the wavelength. So, sorry, speed of the wave. So speed of the wave is 344 meter per second because it's sound wave in our case. Then we divide that by the wavelength 0.75 meter, which is 458.7 hertz. Now that means there will be significant diffraction only for the wavelengths that are larger than the width of the window, and we see that if wavelength is increased, the frequency will decrease. So that means any frequency that's lower than 458.7 hertz, so any frequency which is lower than that will have would diffract when passing through this window. Thanks for watching. I'll see you next time.